What's up, Algebra 2? Here's the plan. We're going to try to cover all of Unit 4 quadratic equations in one day. Wish us luck. So when it comes down to it, you're trying to figure out how to solve quadratic equations, which are things that generally have an x squared to it, and it's going to be a parabola. When it comes down to it, it's a parabola. It's mostly always going to be some type of parabola. Whether or not it crosses the y-axis or it doesn't depends on whether or not it has how many solutions. I think about like rock, paper, scissors because different tools are better used for quadratic equations. Like, let's see which tools you do know. Which methods are familiar with? The default that a lot of people will say is probably quadratic formula. It is the most powerful one. It will solve everything and everything anytime you need to. It is gross. It's very convoluted and it has a lot of steps, and I'm very lazy, and if I can avoid it, I will always try to avoid the quadratic formula. But you do you. Other things that are nice are completing the square. You know I love my completing the square. Factoring is my favorite. And time method is pretty cool. And method, nice. These two are one they're pretty easy. The harder ones you might have like the Xbox. All right, let's go review some of them. Here we go. So when it comes down to it, you always want to be able to make sure everything on one side equals 0. The key here is you're finding the 0. This is why it's either going to be called finding a solution, finding the 0, finding the x-intercept, or the roots. So those are all meaning the same thing. Hey, look, these share common things. 2x. So let's just factor out the 2x. That's going to give me an x plus 4 equals 0. Best way you can think about what does this need to be? What does this need to be for this to equal 0? And what does this need to be for this to equal 0? You can treat them as separate parts. So when we treat that out, that is 2x equals 0, which is x equals 0. And then x plus 4 equals 0. It's going to be minus 4, and that is x equals negative 4. I actually don't want to do that step again and again and again, but I just want to illustrate that that's how you would actually do it. Figuring out the individual parts to equal 0, because anything times 0 equals 0. So if I can get this to equal 0, then it doesn't matter what the other part is. Because right here, if I plug in 0 here, this will be 0. But over here, if I put 0, while I put 0 here, it's going to be a 4. Doesn't matter because 0 times 4 still equals 0. Had I put a negative 4 here, this equals 0. This would be negative 8. But when it comes down to it, 0 times negative 8 still gives me 0. Bring everything to one side. Plus 6y plus 6y. It's an ugly looking 6, but 9y squared plus 6y equals 0. What do we have in common? There's a 3y. I can factor out. That gives me a 3y plus 2. Yeah, equals 0. So I know, well, I was harping earlier, what can it take to make this 0? What can it take to make this 0? The first one is easy because that's just going to be 0. And then this one is going to be the opposite and divided by the coefficient. That is negative 2 over 3. If I plug in negative 2 over 3 here, if I plug in this into this y, the 3's cancel out, and the negative 2 will minus this positive 2, and it becomes 0. You do. That's all you. Got a lot of cover, so I need you to do some work here too. Pause the video and continue on. Now we're going to do some simple diamond method. I like to put the multiply on the top and the add on the bottom. So what multiply together gives me 10, but add together gives me 7. I can think of a 2 and a 5. 2 and a 5. Everything's positive, so everything stays positive. That's easy enough. Let's plug in my factors. X plus 5 plus 2 equals 0. That means y, or x equals negative 5 and negative 2. Done. It's already set. A equals 0, so let's do a diamond method. I get negative 12 on the top, negative 1 on the bottom. Because I know that the top is a negative number, one of these is going to be negative. Which one? Not sure. But I know that because on the bottom it says what added together gives me negative 1. Whatever the larger number in absolute values is, then that one's going to be the negative, so that I remain having a negative 1. But they have the negative 1, so that means they're close enough. So what two numbers, very close numbers, multiplied together gets 12. 3 and 4. Which one's going to be negative? The negative 4. So that way 3 plus negative 4 gives me negative 1. Put that into, this is not x, these are y's. Y's plus 3, y minus 4 equals 0. Then I have y equals negative 3, 4. Done and done. You do. That's all you. You can do it. Splitting the middle and they're both methods solving the same problem. It's when your leading coefficient or the a term is not 1, then can you see it a little more complicated? I'm going to do the splitting in the middle. It starts off just as a diamond method, but you have to take the a and the c multiply together to get the top. Basically, the leading coefficient times the constant is going to be 2 times negative 9 is negative 18, and your bot is still the middle term b, which is just 7. So what two numbers added together gives you, what two numbers added together gives you 7, but multiplied together gives you negative 18. Well, I can think of 9 and 2. In this case, I want the 2 to be negative, so that when they multiply together, you get a negative 18. But when you take negative 2 plus 9, you get 7. So when I factor this out, well, we're going to split the middle so the beginning looks the same and the end looks the same. But in the middle, instead of having the 7, I'm going to change the 7 into a negative 2x plus 9x. Because if I were to combine these two, I go back to the 7x. So it's just splitting it in a way that kind of works out. How you choose which one goes where, you look at what actually would allow you to factor something out. So this will let me factor out a 9. This will let me factor out a 2x. So 2x gives me x minus 1 plus 9. That gives me x minus 1. Hey, like x minus 1, x minus 1. So I can factor those out, x minus 1. That leaves me with 2x plus 9 equals 0. Well, this equals 0, remember? So that means x is going to be 1, and the other x is going to be negative 9 over 2. Good. The advanced diamond method with Xbox, or just called the Xbox method, is very, very similar, kind of, but it has an additional little box that you can draw on it that helps you solve the equation. Bring everything over to get to 0. So I want to minus 4 on both sides. I will get 3x squared minus 4x minus 4 equals 0. That's cool. Let's do our advanced diamond method. 3 times negative 4 gives you negative 12. And I have negative 4 on the bottom. So what two numbers multiplied together gives you negative 12, and added gives you negative 4. These are going to be slightly far away apart, so I'm thinking a 2 and a 6 and a 6. Which one goes? Where's the negative sign going to go? Since it's going to give you negative 4, I will want this to be a negative. So let's split the middle. X squared out minus 4. Give yourself space in the middle. I'm going to put the negative 6x over here. Oh, that's if you're splitting in the middle. I'm actually doing the time method, or doing the Xbox method. So given this information, now plug in what you know. So on the inside of your Xbox, you're going to put your first term. Your first term goes in this spot. Your last term goes into this box. So first box is 3x squared. Last box is negative 4. In between, you can put the 2 that you had just found in the split, going in your 2x and your negative 6x. When you look at these two lines, what can you factor out? I can factor out it. Looking at these two boxes, what can I factor out? I can factor out an x. So an x, if I put a factor an x in here, looking at these two boxes, what can I factor out? And that is a 3x. Looking at these two boxes, what can I factor out? And that is a 2. Looking at these two boxes, what can I factor out? And that is a negative 2. End result, you're going to get x minus 2 times 3x plus 2 equals 0. If you were to play this out, because this x and this 2 times together creates this. Negative 2 times 2 gives you negative 2. This is basically FOIL. X times 3x gives you 3x squared. Negative 2 times 3x gives you negative 6x. That is how the FOIL works. That's how the Xbox works. You're going to get this set, which then gives you x equals 2 and negative 2 over 3. Cool. You do. Next is up to you. Quick reviewer on how square roots work. It is my mental brain to think of it as the Uno reverse card. So when you remember how minus is the reverse of addition and division is the reverse of multiplication, well, the square root is the reverse of things getting squared. So let's do some square roots. The square root is like a fun house in which you can only leave if you find a matching pair. If you're the only 3 in the room, you're stuck in the square root. All right, 81. That can split out to be 9 times 9. Oh, look, I have matching pairs. That's just going to be 9 on the outside. Square root, square root is the same as something to the half power. They're just different notations of the exact same thing. I actually do like this half exponent notation a little bit more because it allows me to cancel things a lot easier when you're doing exponents and the square root that way. But this is way more common. So in this case, if I were to split this out, let's see what I can think of. I think I know 4 can go in there, so that gives me 3 and 2. That's also a 4. There's also a 4. That gives me an 8. And 8 is a 4 and a 2. So this is 2 and 2. There's a lot of 2s here. Bring everything back up a little bit. Okay. So I can this one, and this one, and this one. So that's 4 times 2 gives me 8, and the one that's left behind is a 2. Oh, I could have just factored out an 8 from the get-go. Yeah, I could have. Or I could have factored out a 64. Yes, this divided by 6. Oh, man, That would have been way faster. All right, good enough. 300, the square root of 300, I can do 103, and I know that 100 is 10 and 10. These are my matching pairs that's going to go out, so I go with 10, square root of 3. Then this one, you can also think of it as when you have variables and it shows the exponents, then you just break down to x, and this is easier to think of y squared and y squared. So this is a matching pair, this is a matching pair, matching pair, matching pair. So I have an x, y squared, but there's still an x left in there. Sorry, little x, you don't get to leave. I guess you stay in the fun house. So much fun. Reviewing -1 can be split into imaginary times imaginary or imaginary squared. This is probably one of the most important concepts that you need to know, and hopefully you don't accept. Similar how 9 is 3 times 3 and it can leave the party. -1 is imaginary times imaginary, so eyes can partner up and leave. Since I see this -1 already, I'm just going to bring it out as I, and I have 256. How do I split that up? Off the top of my head, what do I do? I can take out 4. Yeah, I can do 4. My default is always using 4s. And that gives me a 64. Yeah, and then 64 is 8. All right, that's easy enough. So this is 2, so I'm going to pull out a 8 times 2. I can simplify this. 16 I. Yeah, that's done. This one is going to be 9 and a 5. This is 3 and 3. So I can pull out a 3 I, but the 5 stays inside. Sorry, 5, you got no friends. You stay inside. This is the same thing as square root, so let's split this up. I would like to use my 4, so 4 goes into that 108 times. Let's set this up. I'm just going to use another 4. That gives me 227. 27 is, there's a 3s, there's a 9 and a 3. And okay, so I know this goes 3 and 3, and that means I'm gonna be left with 12i square root 3. Paired up. Sadly, that 3 did not have a pair. Trying to squeeze up everything so that it fits. Should have given you all more room. My bad. All right. I can even divide them out individually. So 3, 3. This gives you a to the third, a to the third. This is c and c. This 5 one is the trickiest one, because it's going to be 5, B2, B2, and a B. Sadly, that B is the one that's going to be left behind, because everyone else comes with a pair. So that's 3. It's going to be 3a third, b squared, c imaginary, and there's still a b inside. Alright. Oh, I should have had Drew do most of these. Well, they're done now. Hopefully you understand them. The other way of solving a quadratic is to using the square root method. It's also, in my mind, the shifty solution, because if you look at this, it looks very, very similar to how we had set up to get shifty for the vertex form. aka vertex form zeros or shifty solutions. I like alliterations, so bear with me on how I name things, my naming conventions. All right, since everything's already equal to 0, we're trying to isolate to my x. That's going to give me a minus 12, 3 x minus 2 squared equals negative 12. Divide by 3, divide by 3, and I get x minus 2 squared equals negative 4. Square root, and that gives me x minus 2 equals positive negative 2i. Disappear. Come back. I just wanted to point out this is positive negative because when you're actually doing, when you take the square root of a square, like x, then it's positive negative. If you're just doing the square root of something, you're giving me the natural number. So I didn't need to give positive negative up here. These I don't need to give positive negatives, but this you do because it's coming from this side. If the question was just asking what's the square root of negative 4, then it would be positive 2i. But because you're actually asking what something that was squared and you take the square root of that, then it's going to be positive negative square root. Positive negative that square root. Hopefully that makes sense. I can cover it more in class. Now that I have this, I'm going to plus 2, and I'm going to get x equals 2 plus minus 2i. Happy. Let's do the next one. Minus 6, 2x plus 3 squared equals negative 6. Divide by 2, x plus 3 squared equals negative 3. Square root, x plus 3 equals I, square root 3, since I can't pull 3 out, minus 3, and that gives me x minus 3 equals minus 3 plus or minus, just have this whole thing about plus or minus, I square root 3. Done. You do. Those are for you to do. Completing the square. Then shifty solutions. So if you have your equation already set up very much like this, or quite frankly, if your middle term is even for me and you have no coefficient for the a leading coefficient, so basically it's 1 and this is going to be an even number, I would complete the square. I like completing the square. So that becomes x squared minus 4x plus 4, because it's b over 2 squared. So that if I do it to one side, I must do it to the other side. Plus 4. That gives me this perfect square of x minus 2. Minus 2 equals negative 6. I'm still dealing with a negative number. Whatever. Square root, x minus 2 equals positive negative I 6. I can't pull anything out from that 6. Plus 2. So that means x equals 2 plus or minus I square root 6. Done and done. Next one. All right, let's bring this out to the other side because I want to complete the square here. And I'm going to have 2x plus 10x. I'm just going to add I'm going to give myself space. So negative 27. What's my magic number that I'm going to add into? Plus 25. Plus 25 on both sides. That gives me an x plus 5 squared equals negative 2. Square root everything. I have x plus 5 equals plus minus I 2 minus 5, and then I get x equals negative 5 plus or minus I square root 2. Yeah. All right, you can do. I believe you can do it. The ultimate rock, paper, scissors winner is your quadratic formula. Again, boo. Not a big fan of it because it's just so many steps, so much work. But when it comes down to it, this will always win. It's kind of like playing rock, paper, scissors, and you choose fire because, yeah, you're just going to burn the whole thing down. You'll win, but it's a lot of work. Before we go into that, I do want to break down some of the vocabulary that you should know about a quadratic formula. So this part, the negative b over 2a part, that is the line of symmetry, or the mirror line. So when you have your parabola, it's when you cut it in half, it will look exactly on this side as it will look on this side. Okay. This part over here, the b squared minus 4ac, that is the discriminant. It's kind of the distance away from the line of symmetry. It's important because when you have something like this and the line of symmetry is somewhere around here, it knows it's going to be from here to get to the zero, So the discriminant is very helpful because it helps you understand how many solutions there are going to be. If it equals to 0, that means that from the line of symmetry, there is no change in that point. So there's only one solution. If the discriminant is a positive number, that means it's going to have two solutions. So it's going to be down like this. Here's my line of symmetry. There's a distance here. There's a distance here. So it's going to be two solutions. If it is negative, then I'm going to have a complex solution because there won't be any real solution. Line of symmetry. Does this cross the x-axis? No, it doesn't. It doesn't cross down here. What do I do? It does cross in the imaginary plane. Can't draw the imaginary plane. It says readily, but it's something that's in your imagination, in your head. Think it out. Okay, so let's plug in things. Again, you always want to set everything up so it's equal 0 on one side. I preferably like to put my a, b, c on the side so I know what I'm plugging in. I have -1 here, I have -5 here, and I have 2 here. All right, let's plug a bunch of numbers into a formula. -5 plus or minus the square root of -5 squared, which is going to be 25, minus 4, -1a, and then c is 2, all over 2a, which is 2 times -1. All right, let's break down some of the things that I can do. -5 is just 5, so plus minus square root of 25 minus 4 times -4 times 4 is 4, is 8 over -2. And that can simplify to be 5 plus or minus square root of 17. Really? I chose 17. Oh, wait. This is a positive. Okay, this is a positive. So 33. That's also not a pretty number. Is that anything? Can I break 33? Can I take? No, I can't take anything out of 33. So we're done. All right, next problem. A, B, C. I get A is 3, B is 2, and C is 5. Plugging that into my big giant equation, formula is gonna be negative b -2 plus or minus square root of 2 squared, that's 4, minus 4 times 3 times 5. Ooh, so many numbers, over 2a, which will be 6. So let's rewrite that to be -2 plus or minus, what's in the square root? 20 times 3 is 60. -60 is 54. -54. Not like me to choose such ugly numbers, but I guess I wanted to challenge you guys. Y'all. 54. Can I do anything with 54? What can I pull out from 54? There is 54. Oh, it's 56. My bad. Doing this math. Because it's -4. I make mistakes. But at least I caught it this time. 6. Yeah, 56 is way more doable. Because I can pull out a 4 out of that. Yeah, I can pull a 4 out of there. Which means I'm going to pull up 2. Because this also equals -4 times 14. Yeah, 14. So that's going to be -2 plus or minus 2i square root 14 over 6. I can simplify that to be x equals -1 plus or minus I square root 14 over 3. Quadratic formula. I'm not a big fan of you, but you do give me my answers. Next problem, you do. Go do them. This is my logic chart. This is how I approach quadratic formulas. So if you see it on your final, if it's already in this form, just do the shifty solution because it's pretty much set up for you to do the shifty solution. If you do the shifty solution, you're gonna move this onto the other side, and then divide by a. So that'll be divided by a. That's why it's negative. Take the square root of everything. This is where the square root comes from. That would end up giving something a plus or minus, and then you add the h on both sides. You get this. Should you memorize this formula? No. No. Don't memorize this. I've already asked you to memorize this. If you can memorize this, you can use that to get to here. I'm a big fan of memorizing less, knowing how to convert more. Because this, going from here to here, requires thinking. Memorizing this is not thinking. Just like, honestly, memorizing this is not thinking. But it works. This is just, don't really care. Maybe in a future class or something, I can show you that this is actually just completing the square. It really is, which is why I think it's kind of cool. That's why I love completing the square. All right, so if it's in vertex form, this form, then use the shifty solving. If not, if you have it in general form, like this lovely standard general form, forgot. Here's it goes. If the a value is equal to 1, cool, easy. Can I do a simple diamond method? If I can, yay, do my little diamond. Let's see what can give me -10 and 3. That's going to give me a 5 and a -2. Awesome, let's plug that in. And then I get x equals 2 and -5. Yay. If it doesn't, and they're going to be, there's a real solution, but the numbers might look ugly, then let's see what else can I do. Is the middle term even? If the middle term is even, then maybe I can complete the square and do a shifty. Awesome, that could work. If the middle term isn't even, I don't want to do it, but you'll probably have to use the quadratic formula. You might get away with, it would probably end up being a quadratic formula. That's what you gotta do. All right, if the a is not equal to 1, but there's common factors in them, hey, can I just factor out something so that a ends up to equal 1? Like, look at this example right here. There's a 2x squared, a 6x minus 20. You know what? I can take out a 2. If I take out a 2 out of all of this, then my leading coefficient will end up being back to 1. And you know what? I can go back to this one and check my steps. Quite frankly, if I take out a 2, if I factor out a 2 out of this whole equation, it ends up looking like this. I actually just chose that, multiplied everything by 2. You'll end up with this exact thing, solution for that. Yeah. So, yes, that's great if I can factor out and turn it into 1. If I can't, then please let C be 0. Is C 0? If C is 0, then I can just do easy factoring. That's lovely. That's even the easier thing. I love when it's that. If it's not, boo. I might have to do some diamond method, or advanced diamond method with Xbox, or quadratic formula. there's work. Last but not least, if x doesn't equal 0 and there's nothing in common, I can't factor anything out. Boo. That's either Diamond method or quadratic formula. Yeah, that's not the most pleasant approach to it, but that's how my brain works. In the end, I end up doing a lot of quadratic formula when I need to. But yeah, hopefully I read the way my brain works is check if it's 1, see if it goes here, see if it goes here, see if it goes here. Okay. If that doesn't work, if it's not 1, check if I can factor, see if I can do anything with that, if I can factor out. If not, if I can, then go back to this one. If that doesn't work, see if there's nothing in common. That just means I have to do more work. And it usually just means using the quadratic formula. This page is up to you. I leave this to you. It's optional. If you want to do practice, please practice. If you don't, if you think you're an expert on it, then kudos to you. I'll grade if you need it to. I just want you to have practice because your test is going to be over this stuff. And I want you to succeed. Here you go. Good luck.